Hey, what's up, guys? John here. So today let's take a look at this LeetCode problem here. Number 419, battleships in the board. So okay, so you're given like a 2D board, and you need to count how many battleships are in it. So what does a battleship means, right? So battleship are represented by X, and and the battleships can only be placed horizontally or vertically, right? And and each battleship will at least have one dot in between, right? And the length of the battleship is not limited to one or to any length, right? So for example here, in this like 2D graph here, there are two battleships, right? Because it says the battleship can only be placed either horizontally or vertically, right? So basically any continuous X will belong to the same battleship, right? For example, this one, the, the first battleship is this one, and the length of the battleship is 1. The second battleship is this one, the length of 3. And it also gives you another example here. This is like the invalid examples because it says uh, a battleship, between battleships, it has to be at least one dot in between. And this one, since this is a battleship, this is also a battleship, right? But there's nothing in between. So that's why this one is invalid. Okay, so how are we going to solve this problem, right? So since like you can think of this like array 2D array as a graph, right? And to do that, we can use like either DFS or BFS, either DFS or BFS search, right? Basically every time when we see an X here, right? We know, okay, we see a battleship. And then we just start from here. We traverse all the we traverse all the all the X that's on the same, I mean, that are linked together, right? So by linked together, I mean left, right, top, and down, right? And once that is finished, then we finish the traversing this one ship. And we can also, well, after traversing the every node here, we can just mark this, change the X back to dot so that we won't traverse this one more time, right? So that's the first step, right? So I'm sorry, that's the native approach. Let's try to write this native approach. It should be pretty straightforward in this case. And m equals to length, like board, right? I'm gonna create a board here. N equals to length board 0, right? Then I'm gonna have a directions here, right? So since we're going to traverse all 4 directions, we're gonna have -1, 0, and okay, 1, 0, -1, and 0, 1, right? So, and then we just do a for loop, right? We loop through the entire 2D board. And for j in range n, right? So every time when we see an x, right, then we start our traversing, either BFS or DFS. Board ij is equal to x, right? Then we start our traversing, right? So first, I'm gonna increase this thing to 1, okay? let's do a DFS traverse this time because we have done a few like BFS in the previous videos. So for the again, so for those who are curious about BFS search, BFS traverse, we're gonna have a queue. We're gonna have a queue, and then every time we see the like unvisited X, right? We just move that thing. We just move that. We just add that coordinates to the queue, and then we do this loop until the queue is empty. And for the DFS, right? The DFS is a similar thing. DFS, let's do a DFS. Will be using a DFS like a recursive call basically, and here it's gonna be the I and J, current I and current J. Okay, so we do this, right? And then we simply do a DFS of this current I and J, right? So okay, so here hmm, we do a for loop, right? So first I'm gonna uh, set this current I and current J, mark it to be dot, so that we know this thing has been visited before, right? So that when we see the X, we won't be processing the same X again, right? And then starting from here, we do a loop, right? Directions, right? So new I, current I plus D0, right? Summarize the BFS. Instead, here we're using like uh, a similar to the BFS, we're using a DFS, which is the recursive call here. Basically, we check the boundary check new I, right, M, and um, new J, N, right, and what, and this like board uh, new I, new J is equal to the X, right? Then we if it's X, right, then what do? We do a DFS, right? DFS. We do a DFS new I and new J, right? So and we'll know, so since every time when it reaches here, it will mark this one to the visited here. So I'm not going to mark it here. I'm going to leave this job uh to here, right? At the beginning. So basically after this thing is finished, right? Then uh the all the so for the current ship, right? All the X have been marked as dot, right? Then when this one is finished, right, then we know, okay, all the X will be marked to dot, and then we know we have seen the whole ship already, right? And then we just keep moving until we finish all we have seen all the positions, all the elements on this 2D board, right? In the end, we simply return answer. This should just do it. If I board, okay, typo here. Hmm. All right, cool. So it works so pretty straightforward. So it's just like simple like BFS or DFS traverse every time when you see so X, right? And then you just increase the number of the ships, right? And then in the end, we just do a quick check here, right? So and then we just mark this thing to dot to mark the visited set, right? But then what's the time complexity and space complexity, right? So the space complexity is um it's zero. Actually it's zero, right? And then because we're not introducing any new arrays here, we're just simply using the parameters, right? And then what's the time complexity? The time complexity is going to be since it's DFS and uh, DFS is going to be m plus times basically m times n for each one. We are doing the DFS again, but since it's bounded, right? The DFS will be bounded to the number of x here. So basically, we're not revisiting the x more than once. Let's see. And since the for each of the DFS, right? So for to loop through each node, we need like m times n, and the entire DFS here. That's the so how many DFS will be here, right? So basically, we're gonna have like the number of the x, right? Basically, if there's like x dot in this board, then this DFS gonna like implement something like the number of x here, number of x, right? Yeah, because it's every time once we finish the x visiting x, we will be mark this one to dot, so we will not revisit the x multiple times. That's why we do an add here, right? Okay, cool. I think that's pretty much it is for this problem. And oh, sorry, no, there's a follow-up here, right? Can you do it in, yeah, see, could you do it in one pass using only one extra, one extra space and without modifying the value of the board, right? So I think we're kind of doing one pass with one extra memory, but we're modifying this board, right? And it asks you, can you come up with another solutions with a better like only one pass without extra memory and without the modification, right? Then we cannot use the DFS or BFS, right? Because for the DFS or either DFS or BFS, we have to memorize the which node we had been visited before, right? That's we either do a modification of the board, or we do a extra space to do a scene set to track those, right? So, but it asks us, can you do it without using either DFS or BFS, right? So, how should we do it, right? I'm gonna just like come out this thing. So, if you watch closely, I think it's kind of obvious, because we know, right? If there's like if this x, right? Let's say if there's a x, 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 and dot dot, and there's another like x, 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 right? Let's say this is the board here, right? Let's just ignore all the other dot at this moment, right? So if you see that, so at least for this x, right? If we see x and there's like either like a left or x or right is also x, then we know okay, so this x is part of the ship, right? The battleship. So we can simply ignore it, right? Same thing for this x here, right? So that's why for me, I just come up with a solution here. So we just need to think of, so when should we mark this? When should we uh, increase the count of battleship, right? So for me, I use this starting point. I use the leftmost x, which is this one, and the topmost x to indicate, okay, I've seen a battleship. And so that means if there's nothing on the left or there's a dot on the left, right? Then I mark this thing to be a ship, right? To be a start of the ship. And any x, if there's a x on the left, then it's a part of then it's a part of the ship, right? Basically, I just ignore it. Same thing for this ship, for the vertical ship here, right? If there's a like a x, there's nothing on the top, or 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 the above one is dot, then I will increase the ship count because I know I already found a ship that is placed vertically, right? And then if this x, the top one, if the x above it, if the if the above element of the current x is also x, right? Then we know I can just simply remove it, just like how we ignore. Sorry, I can ignore this one, just how we ignore this one for the horizontal shapes, right? And then we just simply do a loop through each of the dots here. Okay, so let's try to code this thing, right? So same thing, I'm gonna copy this one here. So that's for sure what we need here to do the for loop, and then we simply do a range here, right? Just like what we did for the other one. And so if, right? So still the condition for us is it has to be x first, right? And then we do what we check, right? So I think for me, I think I check if I need to. So basically, I check if I need to continue. I need to skip the current x, right? Basically, I do mm, so I check this one first, right? If the left one is x, then I skip. But we also need to do a boundary check. Basically, if the j is greater than 0, right? Otherwise, there's no left, right? And board I j minus 1. J minus 1 is also x, right? Then we simple skip, continue, right? Same thing for the if I is greater than 0 and board I minus 1, j is x, we also continue, right? And now, since we have already skipped the unvalid start of the ship, then let's check, right? Uh, if j equals to 0, right? That's the starting point. Sorry, if the board j equals to 0, and then we know we have seen a ship, or what, or there's the left one is a dot, or the board I dot j minus 1 is a dot, right? Then we know, okay, we have seen like a ship that had been placed horizontally, like this one, right? Then we do answer plus 1, right? Else, right? So we cannot do a if here because because once we have seen the ship, we cannot mark it again, right? Basically. And else if I equals to 0 or board I minus 1 j and start, right? Then we also mark this one to be a ship, right? In the end, we simply return the answer. Okay, right, let's just run it. Yeah, this thing also works. Yeah, basically in this case, see, it satisfies the follow-up here. Basically, it's still one pass, right? Which uh, loop through the entire 2D board one time, and with no extra memory and without modifying the board. We simply use a bunch of if check here, right? And cool, I think that's it for this problem. Yeah, thank you so much for watching the videos, guys, and hope you guys enjoyed and see you guys soon. Bye bye.